Okay, so we discussed about time, distance, and speed. Okay, and today we are going to discuss the similar concept as work and time. So we learned in the speed, time, distance. The speed was distance divided by time, and if we just replicate the same concept here, what we are going to do, we in the work and time, work will be kind of distance, okay, and time will be same as time, and rate of work will be your speed, how fast you can do the work. So if let's say there is a wall here, okay, I hope I can make it. These are the bricks, okay. Then we see the complete wall, say 5 by 3 feet or meter, whatever you want to call, and some workers, they have to put bricks here for this wall, and they have some, they can put, let's say, 100 bricks per hour or per day. So the unit of the time will be like same as the time, distance, speed concept. It can be in minutes, it can be in seconds, it can be in days, whatever you want to do, or weeks or year or month. It depends on the type of work they are doing. If it's a long construction work, like constructing a new road, it could be like several months. It's just building small wall, it could be a few days, or some task maybe in minutes. So depending on the task, the units will be different. Okay, so that unit is the unit of the time. Work done means like completing the work. So here the goal is make a wall of size 5 meter by 3 meter, okay, by putting bricks. Once this is done, this is one task. And if we say, okay, partially done, so means what fraction of this wall is completed, that's partial work. Let's say workers finished half of the wall, so we can say they finished half work. When they completed the full wall, it can be one work, so half of the work and full work. Okay, so work done, you can always use one work, one, and then time, like how many days, how many minutes, all those things. So look at the similarity here. We have the speed here, and here we have the rate of the work. And distance is the work done here, and time is same. So it's kind of similar concept, but the types of problem will be a bit different. So let's talk about some of the types of problem, what types of problem you can see in this category of concept. So one, like the similar example, wall, let's say 3 workers are working on that, okay? And they can finish the work in, let's say, 5 days. And if you add a few more workers, instead of 3, let's say you want 5 workers. So how many days they will take to finish the wall? Something like that, okay? And then another type of problem could be Mr. A, some person, name I don't know, he or she can do some job in, let's say, 10 days. Okay, another person, Mr. B, he can do work in 12 days. Okay, some work, construction work or building a wall or any type of work. We don't know the type of work. So now they started doing together. Okay, so how many days will it take? So similarly, you can have multiple people like A, B, C, D, and they have their own capability, like how many days will they take to finish the job. And if they start working together, how many days will they take to finish the job if they work together? So these kind of problem will be there. Another type of problem will be like, so this is a tub, okay, here, big tub, and there's a tap water is going here, and there's another tap. So let's say this tap can fill this tank in 5 hours, and this can fill in 3 hours. If you start both the taps, how many hours they will take to fill the tank? this kind of problem. Another types of problem could be like even in this example, there's just some hole here, here some hole, and it it can drain the water in like 3 hours, or let's say it's no, take some big number, 10 hours. Okay. Now if you start this one tap and there's a hole here which can drain in 10 hours, so how many hours will it take to fill the tank? So those kind of problem. And in this type of a work and work related problem, there could be like, okay, multiple people are working, and after a few days some people left. Okay, so how many days the remaining people will take to finish the remaining work? So these types of problem will be very common in this chapter or in this concept. Let's take some examples. Okay, so you remember you have to just use this formula which is similar to this one. Okay, now let's take some example, simple example. I have some questions here. So it says that A can complete a task in 12 hours and B can complete a task in 18 hours. If they work together, how long? So A can complete a task in, let's say, 10 to 12 hours. Some task we don't know. And B can complete the same task in 18 hours. Okay. So how many hours they will take to finish this task if they work together? So in such type of problem, what you have to do, you have to find the rate of that person. Okay. In the unit time, how much work the person can do. Okay. So if that person can finish that work in 12 hours, so in unit time, like in 1 hour, unit time means here the unit is hours. So we have to find in 1 hour how much work that person can do. So if he can finish in 12 hours, so his rate will be, 1/12, correct? Yes or no? He can finish 12 hours one job. So in 1 hour, he will do 1/12 job. Correct? That's why his rate is 1/12. And what is the rate of B? Same. Here, 1/18. So always find the rate for each person. Like in unit time, how much work they can do. Once you have the amount of work done by the people in unit time, you can sum them. Okay? Because they have to finish some part of the work in unit time, and then as the time progresses, they will finish the work. So that's why we start with the rate of each person. Got it? So now I have the rate of this person, I have the rate of this person. What I will do, so A and B can do how much work? 1/12 and 1/18 work in 1 hour. Okay, which is 36 divided by 36. 5/36 work in 1 hour. Okay, correct? Because he can do 1/12 and another person can do 1/18. So they can do, I will add their rate and then we'll find how much they can do if they work together. This is 5/36. I hope I did not make any mistake in calculation. Yeah. Now see, what's happening? Both of these people can do 5/36 work in 1 hour. So now goal is what? To do one work. One work means complete work. So you can write here 5/36 work in 1 hour. So one work will be 1 divided by 5/36, which is 36/5 hours. Okay, or you can use this formula. Okay, from this formula, what you can do, okay, rate of work is 5 by 36 is equal to, I'm using this formula, see how can I apply. Work done should be 1 and time taken we have to find. So, solve this equation. So, time will be what? Since this is denominator, I have to take the inverse. So, time will be 36 by 5, correct? Or simply like cross multiplication, like let me solve here using the cross multiplication. So this is the equation, 5 times time is equal to 36. Let's say time is x, okay? So 5x is equal to 36. So x will be 36 by 5. So 36 by 5 hours, and you can convert it into 7.2 hours, and if you want to convert this into minute, 7 hours, and then 0.2 times 60 minutes, because 1 hour is 60 and 0.2 will be 0.2 times 60, so that will be 7 hours 12 minutes, correct? So see, this is the same thing. You remember this formula and you get the rate for these two people and then solve it. Okay. Now let's move this thing here to the corner. Okay. Rate of work formula will be work done divided by time taken. Okay, keep this formula because as I told you, we solve one type of problem. Another type of problem could be A can do some job in 10 days. Okay, B can do in 15 days. Okay, so rate for A will be what? Let's say rate of A here will be 1 by 10, correct? 10 days, work done 1. So rate for B will be 1 by 15, correct? Now let's say they started working together, okay? And after 3 days, B left. So let's see, if they start working together, A plus B, so that will be 1 by 10 plus 1 by 15, which is 30, 3 plus 2, 5 by 30, 1 by 6, okay? But how many days did they work? Let's say 3 days. So in 1 day, this is rate like work per day, correct? Work per day. Here again, work per day. So they did 1 by 6 work in a day. Now they work together how many days? 3 days. A plus B in 1 day. 1 day, and A plus B in 3 days. How much work they can do? Simple. In 1 day, 1 by 6. In 3 days, 3 by 6. So half of the work is done. So half of the work is done. Remaining will be what? Remaining will be 1 minus 1 by 2, because work is 1. Okay. Full work is 1. So half work is remaining. Okay. Remaining work I have. So how much time? Let's say B left. How much time A will take? So from this formula again. So what is the formula for time taken? Time taken will be, can I just write time taken will be work done divided by rate. Correct? Rate of work. It's so simple. You just move here and move it here. So nothing complicated. Work done. How much work is left? Half work. And what is his rate? For A, 1 by 10. Okay. So 1 by 2 times 10 by 1, which is 5 days. So remaining work will be done by A in 5 days. So this is another type of problem, like started together, left after some time. Another type of problem could be, keep it same as A 10 days, B in 15 days. Okay. A started so his rate will be, okay, I should not have deleted. Rate for A will be 1 by 10 work per day, and rate for B will be 1 by 15 work per day. Okay. So now A started work. He did work for, let's say, 5 days, and then B joined. Then how many days they will take to finish the remaining job? This is another type of problem. So now what we have to do in that type of problem, so A worked for 5 days. In 1 day he can do 1 by 10. In 5 days he will do, so you can say finished work will be in 5 days 5 times 1 by 10, correct? Because A worked for 5 days alone, so his rate is 10. So he will finish 5 times 1 by 10, which is half work. Okay. So he already finished half work. So remaining work will be 1 minus 1 by 2, because full work is 1. So remaining work is again half work. Now both B joined the work and they started working on that work together. So when they started working together, what is their rate? A plus B in 1 day. I will just use 1 by 10 plus 1 by 15, which was like 3 plus 2 divided by 30, which is 5 by 6, 30, that's 1 by 6. So now A plus B rate is, so this becomes rate for the A plus B, okay, which is 1 by 6 work per day. Okay. Now again use the same formula, time rate of work. So time taken will be work done divided by rate of work. Okay, I'm not going to write rate of work. So how much work is remaining? Remaining work is half, because A already finished half, and A plus B, what is their rate? 1 by 6. So basically it's 1 by 2 times 6 by 1, which is 3 days. See? These kind of easy problems. Okay? And the tap and tub problem. So another type of problem, tap and tub. So we are going to use the same concept. Okay, here is a tub. Okay, and there is a tap. And I don't have to explain this, like you two taps are there, how much time they will take, because we already discussed that. Okay, I will talk about the hole. There is a hole here, and it drains the water from here, and it takes how much? Let's say 12 hours to fill the this, let's say, called tank. Because the bathtub it will not take 12 hours to, and this drainage takes let's say 20 hours to completely empty the, if this tank is full, it will take 20 hours to drain all the water, and if the tank is empty, it will take 12 hours to fill. Okay, now both this tank is empty and there is no water, and it's also open, drainage is open. So how much time this tap will take to fill the tank, because water is flowing. So for this tap, the rate will be what? 12 hours. So rate will be work done is 1 and time is 12. So 1 by 12 work per hour. Okay, rate for the, you can say, tap. And it's called A here. Tap is A and call it B. And what is the rate of this drainage? B. Same, work done 1 and time 20. So 1 by 20 work per hour. happening? This one is trying to fill the tank, this one trying to empty the tank. Do you think what's happening here? So effective rate will be what? If one is trying to fill the tank, another is trying to empty the tank, so what do you think the effective rate will be? It's subtraction, not addition. Addition when they do the same job to finish it. Okay? Here, one is trying to not, it's trying not to let it finish the job. So they are doing different thing. One is trying to fill the tank, another trying to empty that thing. That's why when they are trying to do different thing, like two workers are working. One is putting the bricks on the wall, another is trying to remove the bricks. In that case, we cannot sum them. If they are working together to achieve the same goal, then we have to sum. If they are trying to do different goals, here like filling the tank, emptying the tank, they are not trying to do the same thing. So in that case, the effective rate will be the subtraction. So effective, you can say effective rate will be like effective rate of filling the tank will be 1 by 2. This guy is filling, A is filling, so 1 by 12, and this guy is emptying, so 1 by 20. Correct? So let's see how much. 20, so I can 60, 2 by 60, so this is 1 by 30 work per hour. Okay, now I have the effective rate of filling the tank. So time taken will be, again, time taken will be work done, it has to be one work, divided by rate of the work. Rate of the work is 1 by 30, so which is 30 hours. Correct? See, if there was no hole, this would have taken how much? 12 hours to fill the tank. Due to this hole, it took 30 hours to do the same thing. So now you understood the different type of problems you can see in this topic. Okay? And I think I discussed most of them, like, and then if something comes up, we can talk about that. But these are the basic types of questions that you will see in work and time chapter. Okay, let me recap. This is the basic formula. It is similar to what we learned in the time, distance, and speed. It's similar to that. Okay. So rate of work is your kind of speed, and work done is like distance, and then time taken is time. Same thing, okay? So this is the formula. Rate of work will be work done divided by time taken. So we can say work done will be rate times time taken. Time taken will be here. From this you can derive time taken will be work done divided by rate. Correct? And similarly, you can derive work done will be rate times time taken. Correct? All three are same. It's just converting one form to another form, nothing else. Okay? So this is the basic formula. So what we discussed, different types of problem, and then you can use this formula and then try to solve. So the first thing you have to do, like find the rate for like a number of people who are working on the task. You cannot add days. You have to find the rate first. Okay, so that you will find, okay, how much work they are doing in a unit time. The first target, find the rate, and then sum them a difference. Take the difference, like in this scenario when they are doing opposite job. If they are doing the same job, then sum their rate. If they are doing opposite job, then subtract. And then apply this formula to find the date or whatever problem question is asking you. I think I covered all types of problems. And I have a quiz, and there are 10 questions. You can solve those 10 questions. Okay.